And now to introduce our next speaker. Hubert Ströbitzer is a Kubernetes consultant at Kubermatic, helping organizations succeed in their cloud-native journey. The title of his talk is Lines of Defense, Securing Your Kubernetes Clusters, but I heard that there might also be a little bit of Greek mythology in there. So please help me in welcoming to the stage Hubert Ströbitzer.
Thanks a lot. Thank you. Thanks a lot for the warm welcome. As it looks, Kubernetes and security is a big topic. Oh, this was a spoiler. In this edition of Crafthub. By the way, Crafthub, it's already the third time I visit Crafthub. The first two times I was an attendee, so for me it's a big honor for standing on this stage. Yes, imagine the following. You are a person in an organization which is responsible for the security of your Kubernetes environment. If this is a good organizational idea that one person is responsible, that's another question, but let's imagine that. And you are doing that. So you are very performant in what you are doing. And guess what? The management loves you. Because you do an awesome job and they don't have a clue what you are doing. And if you say it's safe, then they say awesome job. And even better if you only needed a few hours for making something more safe. Then imagine the something which happens next. You are going to the office again, grab some coffee for sure, go to your workplace, open your laptop, and check emails, close emails again because they suck. And then you read tech news, and hooray, you are in the media. But this kind of media you don't want to have, typically. What do you do next? How to tell this to management? Because probably now they will look like these guys. And to give you some ideas about tools around Kubernetes security, yeah, I will show you some tools. There are a lot of other tools out there, so this is not opinionated or in any way. I find those tools very useful. And the main takeaway of this talk, if you're responsible for security, you have to be solid as a rock. The management might not like your answer to the estimate. Maybe the developers do not like that they also play a big role in the security topic. So you are the one responsible for security if you're in that position. So be solid as a rock. A few words about myself. I'm Hubert, I'm coming from Austria, so it's the country where also Arnold Schwarzenegger comes from, so the strange accent, yeah. I'm doing Kubernetes stuff at Kubermatic since about 3 years now, and in Kubermatic, it's all about Kubernetes in the end. I did 12 years of software development, mostly in the Java environment, on the JVM, so Java, Groovy, Kotlin, Scala. I like to talk tech, and I'm a Linux Foundation trainer for CKA and CKAD, and I also contributed some questions to the CKA. Before we go to the tooling and the lines of defense, I want to bring up some things which most of you probably already know. What is a Kubernetes cluster? If we have a Kubernetes cluster, we have some virtual machine or even bare metal machines. And there are two different types of machines, the master nodes and the worker nodes. And the master nodes, this is the brain of Kubernetes. This is Kubernetes, and the worker nodes, this is where your applications are running. So if you do a kubectl apply, then some container in the end will be started at some worker node. On the master node, we have etcd. That's the database. All the state of your Kubernetes cluster is in etcd, not the state of your applications. This is somewhere else in your whatever database you use. But the state of Kubernetes is in etcd. The only component allowed to talk to etcd is the API server. It's a very important component. We will talk about this a little bit later. Then there's the Cloud Controller Manager to get a load balancer or to get a persistent disk or even a new VM. The Cloud Controller Manager knows the cloud where the Kubernetes cluster is running in. There's the scheduler making the decisions where to run what. And the Controller Manager, Kubernetes, the architecture of Kubernetes is very simple. Those are only some endless loops which try to bring the desired state into reality. Those loops are called reconciliation loops. And those are managed in the Controller Manager. And that's it for the master node. We only have one master node. For sure, you should have more than one master node, but this will be on the next slide. On the worker node, we need some container runtime. Can be Docker, can be containerd, can be cryo. So this is where your applications will be run. Kubelet is also a reconciliation loop, but running on a specific worker node. And the kube proxy, which is about networking. So if you apply a service to your Kubernetes cluster, some IP tables rule have to be changed probably, and that's the job of kube proxy. From the communications point of view, I already mentioned that API server is the only one which is allowed to talk to etcd. And all the others are talking to the API server. So that's the reason why the API server is that important. Everybody is talking to the API server. Also kube proxy and the kubelet. One thing which is interesting, the API server is also talking to the kubelet sometimes. For example, if you want to have a log file, or if you do a kubectl exec, then this is a situation where the API server is talking to some kubelet. And the kubelet is talking to the container runtime to start and stop containers and monitor them also to some degree. And we are talking also to the API server. So if you do a kubectl apply or whatever, then you are talking to the API server. You can find this information in the .kube config in your home directory. etcd, it's not part of the Kubernetes project, so you can also run it for sure outside the master nodes if you want to. A more realistic scenario is this one. So we have 3 worker nodes because high availability and 5 worker nodes. Typically, you have 3, 5, or 7 master nodes. More master nodes doesn't bring you more performance, so it's also stated in the Kubernetes docu, 3, 5, or 7 is fine. One thing I didn't mention was the CNI plugin. The containers have to be able to communicate to each other, although they are not running on the same machine. And that's the job of the CNI plugin. The CNI plugin is not part of the Kubernetes project. The Kubernetes project only provides an interface, which the CNI plugin vendors have to implement. Examples, Kernel, Flannel, Calico, and Cilium. A few words about installation, the hardware. There's a Git repo by Kelsey Hightower, which is called Kubernetes the hardware. I can highly recommend to do this. Workshop kind of thing, to install a Kubernetes cluster by hand. What you will do if you do that, you install your Kubernetes components via Linux services. Like this one, this is a Linux service for the kubelet. And we have already seen this. Yeah, you have some master node and some worker nodes, and the components are running, as we have already seen. The smarter way, and there are several smarter ways than doing it by hand, is, for example, with kubeadm. Basically, if you do this, you get the Kubernetes cluster. One thing which is very interesting on kubeadm, and a lot of other tools are using kubeadm, like kube1. So other tools you may know use below the surface kubeadm. And one very interesting thing is the static pod path. So you can tell the kubelet, which is still running as a Linux service, that there is some specific directory where some pod manifests exist. And these pod manifests will trigger that the kubelet will start those containers in the end. This directory is only about pods, not about deployments, not about stateful sets, and so on, so only pods. And if we start something with kubedm, you have, for example, etcd, kubeAPI server, kube controller manager, and kube scheduler in this etc Kubernetes manifest directory. We will fiddle around with the kubeAPI server a lot. By the way, I forget, if anybody has a question, please feel free. This should get interactive, so no monologue. Okay. And this looks then like this. Yeah, you see it. So we have the container runtime running some pods. And this is exactly what we are doing in the labs. I prepared some cluster with kubedm, and this will look very similar. How to install Kubernetes like a boss. The company I'm coming from, we are installing Kubernetes. That's our daily business. We have a product where we install, which allow you to install Kubernetes clusters. Yeah, hundreds of Kubernetes clusters, and actually customers are doing that. We use something which is called Kubeception. In yesterday's talk about virtual clusters, this is the same approach. So what you can do, or what the concept Kubeception means, is you have some very specific Kubernetes cluster, let's call it the seed cluster, which runs the control plane for the other user clusters. And you have a lot of benefits out of that. You have very low resource needs because a VM is bigger than a container. Starting clusters is very fast. We are talking about 2 minutes. Because containers start faster than VMs. And you can make use of the whole Kubernetes toolset. So liveness probes, readiness probes, rolling updates and stuff like this. So looking back after 3 years, I think this idea is great. Oh, sorry. Okay. Some visualization of that. If the monitor works. Okay. So there's the seed cluster where you have some namespaces like the user cluster namespace, and then you add some worker nodes to it. Should I try here something? Or? Okay. Okay. And you add the worker nodes to this user cluster. So this is then a user cluster. And you can do this multiple times, as you can see. But now, to something completely different. Who is old enough to know Monty Python? Yes. Yeah, it is an ops-ish talk. Typically, the people in the ops talk are older. I want to tell you a story. How King Admin the naive become King Admin the proactive. That's some Greek mythology topic, story, which was found last month in Austria. I think it was written down by Socrates or whoever. And let me introduce you to the main persons. That's King Admin. That's not me. He does more gym than me. But that's King Admin, and King Admin is loved by everyone. He's a very wise king. He's a little bit naive. He already has chosen Kubernetes. His kids love him. His pets love him. Everybody loves him. Even his ex-wives love him. And King Admin made some wise decisions already, and he's the king of a big kingdom, which is called Kubopolis. Yeah. Looks like a metal band logo. And this looks like that. So this is kubeadmin, King Admin, kubeadmin. And you see on the left from your view the King Admin, and there are some buildings which look very nice. And these buildings have some names. Yeah, you probably know them. So scheduler, API server, etcd, cloud controller manager, and controller manager. This is the main city of Kubopolis. There are some small suburbs around this big city, and there are also some buildings in there. kubeproxy, kubelet, and the container runtime engine they are called for whatever reason. And these boxes on the left, I think from your view, there are also some craftsmen. So, like in the big Greek polis, which are autark and autonomous, not everything is done in the big city, because it doesn't make sense to do farming in the big city or to have smiths in the big city. So those are the craftsmen which are in the suburbs. Let's call them worker nodes. And there's also an evil villain. Nobody loves him. Hakarios. Okay, this is the lab environment. We have, in this case, a single node Kubernetes cluster. It's a real cluster. It's no kind cluster. It's no minikube cluster. It's a real cluster. And yeah, it looks like this. We have kubeadm, and so we have a container runtime also on the master where everything is running kubeproxy. So in the container runtime, API server, etcd scheduler, and controller manager. The only thing which is not running as a container is kubelet. That's a Linux service still. Now, Hakarios attacks everywhere. It's about firewalls. It's the most important thing at the beginning, probably. Yeah, Hakarios is here and wants to do bad stuff. What you have to do for sure is build proper firewalls. And also, King Admin has a great idea and builds walls around these cities. And you see there is a big hole in the middle of this wall. You have to open some ports in the end. Which ports you should open in a Kubernetes world? That's not a list of ports you should open. Which ports do exist in the Kubernetes world? Port 6443 is the API server. So if you want to talk to the Kubernetes cluster, you have to be able to reach the API server. It depends a little bit on your context. If you have an on-premise network and everybody is in this network, then things are more easier. If you're in a remote team and you have probably some VPN to connect into this on-premise network, then for sure you can also do firewall stuff. It depends on your context. If you open the API server to the whole internet, which is not a good idea. There are some internal ports you shouldn't open at all, like etcd, kubelet, kube scheduler, and kube controller manager. On the worker nodes, there's the kubelet. As already mentioned, the API server sometimes wants to talk to the kubelet, so this kubelet has to be reachable also from the API server. And depending on your ingress strategy, you may have to open the port range 30,000 to 32,767, which is the default port range for node port services. So if you expose a service on your Kubernetes cluster via type node port, it will get one of those ports. And if you reach one of the worker nodes on this port, you have exposed basically your application, which is typically not the case because you are using ingress or service mesh or stuff like this. And now it looks like this. So we have now proper borders around our cities and also around the main city. Now he takes the suburbs, and now it gets interesting. So for whatever reason, Hakarios is in a suburb. And now live coding will happen. I hope so. By the way, I will do a lot of stuff now, and a lot of stuff can go wrong, so I hope to get it done, but let's try. I even brought with me my keyboard because I have a different layout on this one, so let's try it. Where am I? Here am I. So what you see here is my Bash, already connected to a virtual machine running at some cloud provider where Kubernetes is running. Is it readable for you? There's nothing in there. Below, besides the fact that this doesn't give any sense now. Okay, so we can do a kubectl get bots, if I write it right. yeah, you see in the default namespace there is some pod which has a very interesting name, my suboptimal pod, and this pod is really suboptimal. We'll talk about this later. As we have seen previously, Hakerios is attacking the kubelet. So let's try this. Besides some installation things I did on this machine, I also have some environment variables like this one. So this is the IP address of this Kubernetes cluster, so it's easier for me to do stuff. So let's do this. And I have my cheat sheet here, so hopefully do not too much typos. Otherwise I have to copy paste. So let's try to get some information out of the kubelet. The kubelet is running on port 10,250, and let's check if we get some metrics, because probably Prometheus is scraping stuff from the kubelet. Oh, that's interesting. We didn't have to authenticate and authorize ourselves. Currently, this cluster, everybody could do this. Please don't do it on this IP address. It's completely open. So if the kubelet is available from the outside and you do some bad stuff with the kubelet configuration, you don't want to expose stuff, typically. And it even gets worse. Let's take a look if we can get some log file. Oh, yeah. That's interesting. We have a lot of log files here, which we can grab. And for example, and we have all the log files available from the pods which are running on this machine. That's bad. Let's fix this. No, not fix it yet. I want to show you something even scarier. If Hakerios wants to steal some identity, he can do that. And I copy paste this because it's too much to write. We send a post request to the kubelet, and we run a command at some specific pod, at the suboptimal pod, in a specific container, and we say, give me your service account. And guess what? You get it. Awesome. Not awesome. And due to the fact that this pod is privileged, so he can access stuff on the host, and I mounted something into the, maybe let's show it to you. I will show you the suboptimal pod, and you will see it multiple times in the next hour. Yeah, we have here some crazy volume mounts. So the host path is mounted to host in the container, which is a very bad idea. Which allows us to do the following. To check what users exist on this machine. And you can even change files. So you can create a new user, change some password, create a password for the user, and you are root on some worker node of a Kubernetes cluster. So let's change this. And typically, these things do not happen if you have some managed Kubernetes. But if you're building your own Kubernetes environment, be aware of such things. So let's take a look at the kubelet config. Let's write kubelet config. And the problem is the authentication and the authorization part. Anonymous authentication is allowed. We shouldn't do this. False. And also authorization, always allow, is not a wise choice. Let's do webhook and save it. And due to the fact the kubelet is a Linux service, we have to restart it. And ctl restart kubelet. And now connection refused. So make sure your kubelets are safe. Good. Any questions from your side? Then to the next attack of Hakerius. Let's see. Yeah, now the kubelet are safe. Cool. So Hakerius now really tries to steal some information, although the kubelet is already safe. If, for whatever reason, Hakerius gets access to some worker node because he's from a third-party company and he has to do some consulting, he can still do scary things. So now Hakerius is here, and you see in the pods there are some small keys. And in Kubernetes, the default is that each pod has the service account token inside the containers. That's the default behavior. So if you start the pod, there's the service account token in there, and even other stuff. The question is what one can do with the service account token. Yeah, this depends a little. We have to talk about authorization modes of the API server. So node that's needed for the kubelets to talk to the API server. ABAC, the old one, nearly nobody cares about this anymore. RBAC is role-based access control. I will explain in a few minutes, which is nowadays the default, and webhook for sure. And you can customize this in the API server with this authorization mode flag. And the default typically is node and ABAC, so you can also combine that stuff. What is ABAC? ABAC is about permissions in a Kubernetes cluster. So you have cluster roles or roles. A cluster role is for the whole cluster. A role is for a namespace, for a specific. And you have rules. For example, get, list, watch pods. So the rule says, if you hold this rule, you can get, list, and watch pods. Now the question is how a user gets this rule or role, and how a service account gets this rule or role. A services account, so your applications, for being able to talk to the API server, it has to have a service account with proper permissions. So if you're talking about service accounts, we are talking about applications talking to the API server. When we are talking about a user, we are talking about a user. Another question is how we can combine those two worlds with a cluster role binding or a role binding. So a cluster role binding, again, is for the whole cluster, and the role binding is for a specific namespace. And basically, those are only pointers, so I can say the user has this cluster role, or the service account has this role. So let's play around with that. And it's damn hot on stage, to be honest. So I have to switch to the CLI. We are still on the Kubernetes cluster host. And now we don't want to do identity theft with the kubelet. We are simply trying stuff with existing pods. My suboptimal pod. And for sure we can send commands in. There is this very famous path, var run secrets, and I have no completion for sure. Kubernetes.io service account token, and I hopefully haven't done any typo. So by default, Kubernetes stores the service account token below this path. And let's see if we can get it. Great. Yeah, or not. And also, we need a certification authority. And even this one is in there. So if somebody has access to your Kubernetes cluster, he can get a lot of information out of the pods. And now let's try to use this information. So I will store that stuff. This one I will store in an environment variable. So now we have the token in the token variable. And let's store the certificate in a file. And imagine the following. Somebody has access to your Kubernetes cluster for 15 minutes, takes this information and leaves the organization, and for whatever reason has access to some worker nodes. Then he can do a lot of crazy stuff. So let's use now the file and the variable with a create curl request. And I have to copy paste, otherwise I would make too much typos. So we are curling now the API server. And we want to have information which pods are running on this Kubernetes cluster. And we get this information. That's also an issue. So the reason why this is doable on this cluster is because there's a very super optimal cluster role binding. So let's take a look at the cluster role bindings. Get cluster role bindings. Okay, I have to grab my suboptimal cluster role binding, which basically binds the service account of the default namespace to cluster admin. In cluster admin, you have all rules. You're allowed to do everything, basically. So let's change this. Simply delete the cluster role binding. Whatever. And now let's curl again. And it shouldn't work now. And we get the forbidden, and that's good. So, most of you are aware of the least privilege principle. Really use it. Otherwise, somebody can steal some service account and can do scary stuff. Let's check in our Kubernetes cluster what's defined in the API server. So we do a cut etc Kubernetes manifests kube API server. And this is the static pod manifest for the API server. Here's the command kube API server, and we have node and RBAC defined here. Okay, that's fine. Okay, so we also fixed this problem. Any questions from your side? Okay. Then going back to the slides. One thing I didn't show you, but which comes in very handy here, is you can add this specific field to your manifests, automount service account token false. If you do that, the token is not mounted in the container of the pod. The default is true. So by default, the tokens are in your containers. If you set this to false, you are not in this situation. Yeah. Now, due to the automount service account token set to false, the keys have disappeared. So Hakarios can't grab them anymore. And now a big topic. Encryption. Everybody loves encryption. Bad joke. And we have to discuss encryption at usage, transport, and rest. There are 3 different levels. And also our Kubopolis view looks very scary because Hakarios can attack a lot of things. For example, the roads between there are roads between the buildings, and Hakarios can also attack the database if we don't encrypt the database, and he can also attack if he has access to the pods. So the sensitive data at usage in the end. So we have to talk about encryption at rest, encryption in transport, and encryption in use. So at rest, typically database disk. In transit, when some sensitive data gets sent over the line. and in use when your application is basically using the sensitive data. Encryption at usage. So here you see Hakarios trying to steal some secrets from your containers in the end. And also, he tries to steal stuff from your Git repo. That's the next question. How do you store your sensitive data in your Git repos? Do you encrypt stuff in your Git repos? Are your Git repos open source? Then you probably should encrypt stuff. And there are tools for this, like Git-crypt or Mozilla SOPs. So you can encrypt stuff on Git repos. Let's talk about the first case where Hakarios wants to get some sensitive data from your containers. Now the infamous topic of secrets in Kubernetes. The big point, all faux secrets sounds like that they are secret. They are not. Secrets are only base64 encoded, and that's no encryption. The good thing is all the secrets get stored inside the containers in a temp file system, so they never touch a disk, although you mount them as a volume. So secrets are not mounted on a real disk, they are only in a temp file system, so in memory. Yeah, and inside the containers, the applications expect the secrets in plain text, so they have to be in plain text. So they are even base64 decrypted, and we will see this in the lab. Exactly. So, sorry. Here we go. First of all, create the secret. Create secret generic my secret minus from literal, so we do it with a one-liner. And let's call it password equals password 123 because. And now the secret got created. My secret. Damn it. My secret. And we can take a look at it. And we see the password is in the data section here, which is not password 123 because it's base64 encoded. So let's try this. If we want to grab only the password, we can do the following: JSON path equals. Damn it. And now we can define the exact path where the data is what we want to have. So data password. And we see it's the base64 encoded password. And now we do decode this one. Et voila. So secrets are not secret. That's the point. Now let's use it in a pod. So we changed our pod and add the secret volume mount and also the secret volume for sure. And we have to apply the pod for sure. Minus force. No? Yes. So let's take a look how the secret looks in the pod. So we do a cube cattle exec minus it my sub pod. ls minus lh secret. So let's take a look at this directory where we mounted basically the secret. And there's a file in there which is called password. So the key of the secret has become the file name. And if we cut this one, we see it's in plain text for sure, because the application expects it in plain text. That makes sense. Was there a question? No. Okay, most of you probably already have known that. One thing I want to show you, additional to secrets, how do secrets look on host level? And let's do the following. Let's take a look on host level on those volume mounts. And so we grab the temp file system mounts like this. And those are the temp file systems on the host. And this looks very interesting. So I have to copy paste this. And let's do a cut. That's true. And also, the stuff is reachable on the host, which is not very nice. So if somebody has access to your host, he has access to all the secrets. And the secret can be a database password or whatever, or API key or whatever, what your application needs as a secret. So this is also something you should be aware of. And yeah, that's for now for the secrets. I will come to this a little bit later back again. First, I want to talk about encryption at transport. And if you're talking about encryption at transport, we are talking about when sensitive data goes over the line. So, for example, if the cloud controller manager is talking to the API server, what is when somebody intercepts traffic, is data encrypted or not? Or if we are going maybe over the internet to a worker node, is data encrypted or not? And also, if your applications talk to each other, so you have some microservice, A and B, and A wants to talk to B, probably they are not running on the same host. And the question is data encrypted when you do such things? And let's take a look how this looks in our cluster. First of all, there are some good news. And I'm a Kubernetes fanboy, by the way, so I don't want to blame stuff here. Kubernetes is awesome, but I want to show you some things you should be aware of. If you take a look at the Kubernetes BKE, you see a lot of certificates in there. So between the Kubernetes component itself, there is encryption in place for sure, depending how you created your Kubernetes cluster. But in general, the keys and the certificates, in the case of kubeadm, you can find below this folder, and those are for sure are also used. The one which is not in there is the one for the kubelet conf. So let's take a look at this one. For sure, it's also encrypted. So if the API server wants to talk to the kubelet, for example, there is also some keys and certificate stuff in there. So for the Kubernetes components, we are safe. What about if I talk to the Kubernetes cluster? I, as a developer, I want to deploy my application. And in your home directory, there is some very interesting file, which is below .kubeconfig. And this kubeconfig basically holds, in this case, inline all the certificate data and the key data, and also the API of the URL of the API server. So all the information about communication with the API server is in this file. And you can have more than one clusters in this file, by the way. And tools like kubectx and kubens basically manipulate these files. So all the tools where you can switch namespaces or you can switch clusters, they are very stupid. They're only manipulating this file. You can also do this manually. One last thing I want to show you. If you really have to maintain your Kubernetes cluster by hand, you have also some tooling in place in case of kubedem expiration, so you can check when your Kubernetes cluster components run out of, are invalid, become invalid. So you see this, and you see all the information about your certificates. And to make it clear here, if one of these certificates get invalid, you have a big problem. Your Kubernetes cluster will not work anymore. So you have to take care about this. And typically, you should do your Kubernetes upgrades very often. So, for example, all 3 months, because all 3 months a new Kubernetes version comes out. And typically, if you do the upgrade with kubedem, those certificates get updated automatically. But you can also trigger this manually. I will not do it yet, but I can show you how this works. Yeah. So with certs renew, you can either recreate all the certificates, or you can be very specific about this. And so now we know that the communication between the Kubernetes components are safe, as long as you have valid certificates. I also mentioned that the question is, what about your applications? Do they also have encrypted communication? And the answer is no. So although the Kubernetes components are discuss to each other in an encrypted way, your applications do not use any encryption by default. And it depends a lot of your context. So if you are in the e-health world or doing some government stuff, yeah, encryption would be nice. So you have to think about this. And one nice tool, there are also other nice tools, would be Istio. You get a lot of stuff with Istio. But one thing which is important here is you get also encryption, so mutual TLS of your services. And that's the default. That's the cool part. So if you apply Istio to your Kubernetes cluster, you get a lot of stuff. And also your applications which have the sidecar proxy injected into your pod will get encryption by default. So Istio works this way. Istio is admission webhook which injects a sidecar into your pods. In this case, the Envoy proxy, which takes over all the communication from your application. And that's the perfect place to do TLS termination, and that's exactly what's happening in the Istio world. So TLS termination will happen in the Envoy proxy. And the question is, how do these Envoy proxies get the configuration and also the certificates? That's the job of the Istio control plane. So basically, Istio control plane takes care that the certificates are renewed and stuff like this. So if you apply Istio, you are also safe. I was once in a project many years ago. Istio didn't exist at this point in time, where we implemented this TLS termination inside our applications. And I will never, ever do this in my life again. It's horrible. So you have to renew your certificates, which means your applications have downtimes, which was a big pain back then. Use some automation tool, like Istio or something else. Yeah, I already have spoken about this. So now also this line, which was black at the beginning, now is green. So also our applications can talk to each other in an encrypted way. Encryption at rest. Now it gets scary for me, because this didn't work. The probability that this doesn't work out live is very high. When we talk about encryption at rest, we are talking about etcd, because the only component which is holding state in the Kubernetes world is etcd for the Kubernetes world. For sure, your application also a holding state, but somewhere else. And now Hacarius tries to do fancy stuff with our etcd. And before we go to the left, there's something which is called encryption config in Kubernetes. So you simply have to apply this encryption config. And the default is it is not applied. So if you create a EDM cluster, by default, the stuff is not encrypted in your etcd. And you can tell the API server which of the objects should get, of the resources should get encrypted. Secrets sounds sane to me. And we will do this afterwards live. So we add this encryption config to the API server, and starting from that point in time, everything gets encrypted. So let's try this. I have to switch to the terminal. Where is it? Here it is. And I have to open my cheat sheet. We are taking a look at the etcd configuration on this machine. So Kubernetes manifests etcd, and you see here that you have some very nice URLs and certificates and keys. Typically, you need those informations to talk to your etcd via etcd control. So there's a command line tool for etcd, and this we will use afterwards. Typically, you take a look at this file, and you can talk to etcd in the end. I did this via environment variables, which you can also do to make it a little bit easier. The last thing I want to show you on the configurations part is in the kubedm world, all the stuff. So the data of etcd is stored on the host here. So here, etcd, which runs in a container, stores all the information on the host. So let's try to get our secret from etcd without using Kubernetes. Etcd control get registry. There is no completion here, so I do a lot of typos. Secrets default, that's the namespace, my secret. We created this a few minutes ago. And you see, password 123 in plain text. We don't like that. So let's change this. I have this encryption config located already on this machine, and now I'm in the situation that I have to move the encryption config to the API server container. I prepared some stuff in here, so I only have to move it into a specific folder, which is mounted to the API server, so that it's easier to show for me in the end. So let's do this. It's the encryption config, and we put this into root API server. And this directory is mounted in the static pod for kube API server, and the file is available in the API server. Cool. Now we have to configure it, and now some serious, no, not good. API server manipulation. Manifests kube API server. And copy paste for sure. Safety first. So we add some flag here to tell the API server, please encrypt stuff. And in this encryption config, we say, please encrypt secrets with this randomly generated key. So we changed the pod manifest of the API server. Now the kubelet will restart the API server. And if we do now a kubectl get pods, the cluster isn't working anymore because we have a single node cluster. Yeah, because we have a single node cluster. So we have to wait for a few seconds, then the API server gets available again. So we can also take a look at the running containers on this machine. And this one was started 2 hours ago. And this is the one which should get terminated very soonish and restarted very soonish, and hopefully the API server can restart. Otherwise, I have made some stupid typo. So kube, maybe it already works. So it's running again. And if we take a look at the API server, it was started 26 seconds ago. So the kubelet recognized, oh, this file has changed from the static pod manifest, and restarted the API server with the new settings. So we don't have to do anything else here. So let's check if this encryption config helps in our problem. So we do etcd control get registry secrets default my secret, and
You missed an R.
Ah, yeah, thanks. It didn't help, and that's okay, because the secret existed already before. So the encryption config only is for newer secrets. So let's try this. So create secret my generic my secret 2 minus from literal password equals password 456. So we created a new secret, and now the question is this one encrypted? For me, this looks encrypted. So new secrets are now encrypted. But what about the old secrets? For sure, I also want to encrypt them. And there is one ugly hack for doing this. And I do some serious copy-paste. We simply rewrite all the secrets. So we create new versions of the secrets. Cool. And now, also our first secret is encrypted. That's fine. Are we done yet? Do you think we are done with encryption at rest? Nope, we aren't. Because encryption is such a great topic to talk about. We will talk a bit more about encryption. What about the backups? And now it gets, in my opinion, really a little bit scary. So let's do a backup of the etcd. Snapshot save backup db. Doesn't matter. So we have a backup. So let's try if in the backup we have some plain text passwords. Password. Let's try the second first. No, that's fine. So the one we created encrypted is not in the backup. This makes sense. Now let's try the first one, which is already encrypted in the etcd database. And it's still in there. Why is it in there? And the reason for this, I want to show you on the slides, is this is some etcd stuff you should know. etcd is copy on write stuff database. So if you create a new version of a data some key, the old version still exists, and the new version has a new revision number, but the old version still exists, and that's the reason why the password 123 is still in the backup. So let's change this, and for doing this, I have to switch back. I have to get the latest revision number of etcd. And we get this information via this command, so now we know the latest revision of etcd is 17,817. And we have to compact the database and to defrag the database. Typically, etcd does this in periods of 5 minutes, but you can customize this. So let's do this. So the compaction is done all 5 minutes, as far as I know. Etcd control compact. What was the number? And now data got compacted, which means the old revision should have, hopefully, are gone, are not in the backups anymore, or will not be in the backups we create now anymore. So let's try this, create a backup again. Let's call it whatever 2. That's completely wrong what I'm doing. Etcd control snapshot save backup 2 db. And let's check if the password 123 is still in there. And now it gets very interesting for me. Password 123. And it's not there anymore. Because I'm preparing for this stuff, I recognized that sometimes it was still in there, although I did the compaction. And then I even had to do the following. I had to do a defrag. So etcd control defrag, which probably really moves everything which is not needed anymore away. So yeah, this whole topic can get very tricky. That's very visible here. Yeah, sure. You have to delete the old backups. Exactly. The joy of being an admin. So what we did now is we also made this etcd safe, so you can see it very good here. It's also in some greenish color. And coming back to your question, for sure it's important where you save your backups. So if you have your backups in plain text available somewhere, and somebody can grab this etcd backup and you have plain text passwords in there, I do not think that's a good idea. So now we're here. Some things, because I wanted to give you some follow-up on secrets. You can use HashiCorp Vault, so no secrets get stored in etcd anymore. You can use HashiCorp Vault, which injects a sidecar and an init container into your pods, like Istio does with a mutating admission webhook. And you get the secrets from the Vault server. This thing you can do, or even, and you have to put some annotations into your pod specifications where to get these secrets. So the secrets are not stored anymore in etcd. This is one way, and a very similar way, but it's even more hip, is using CSI secrets provider. So what's the container storage interface? What's CSI? It's an abstraction. In the past years, Kubernetes delivered a lot of volume plugins in tree. So which means inside the Kubernetes project, the persistence vendors implemented their stuff, and you got this plugins via installing Kubernetes. I think this project already started 3 years ago, or even 4 years ago. So the Kubernetes project decided that's not a good way, because the storage vendors have a different life cycle, and they want to release whenever they want to release, and not when the Kubernetes project wants to release. So another abstraction was created, which is called container storage interface, where the storage vendors can create their plugins without having to deal about the Kubernetes release cycles. And one of them is the secret store CSI driver. So in this case, it's very similar to HashiCorp Vault, but maybe it's a little bit nicer because you do not have to use annotations. The kubelet will take care that the secrets get mounted wherever you want it. We are talking to the CSI driver, to the CSI provider, which talks to the secret store. And the secret store can be, again, Vault, or can be something from Google, something from AWS, something from Asia, and more to come. So again, all the secrets will not be stored in etcd at the end, somewhere else. And yeah, you have to apply this provider to your cluster. And this is how you configure it in your pods. You don't have to use an annotation. You simply have some CSI driver, which you add in the volume section. Yeah, it's still in alpha phase, so not that usable yet. And support for AWS, Azure, GCP, and Vault. And now, King Admin becomes proactive. And he is, because he was visiting the Conf back then in Budapest, so he learned about some new tools. And the first thing he heard was static pod analysis and image scanning. So first talk about static pod analysis. So somebody wants to talk to our API server and wants to apply some pod in our Kubernetes cluster. And also Hakerios wants to do that. And is there a way that we can prevent strange pod manifests? Yes, via static manifest scanning. So let's try this out. The tool I'm using here is kubesec. And it's very straightforward if I find the terminal. Let's scan our pod manifest. And we get the JSON structure back. So in general, it's valid what we try to apply to our cluster now, but we have a score of -37, and that's not a good score. And the reason why this is not a good score is we have two critical issues in our pod. First of all, we use privileged, and second of all, we allow privileged escalation. So we will change this. We also have some advices here about AppArmor and service accounts and resource requests and limits. So let's fix the critical stuff now. So privileged false. False. Run it again. And now we have a score of 0, which is better. Let's try to get fancy and get to an even positive number. I have to be a little bit careful here because otherwise I have some problem in other labs. Let's do not run as root user, which makes completely sense and is a very important point. And also, we want to add the resource requests and limits, which is not only from the security's point of view a very wise choice, also you help the scheduler a lot to do wise decisions. And I did something wrong. So let's do the scan again. And now we have a score of 6. Yeah, and you get it. You can fix a lot of things. So it's very handy, it's very straightforward. And pro tip, do this in a CI/CD pipeline. And pro tip turbo, you can use this as a cron job in your Kubernetes cluster. So grabbing your pods from the API server and check in your prod environment if this is sane or not. Image scanning, I will not do the demo because I'm running a little bit out of time. And also, you have seen image scanning multiple times on this conference. Adrian showed a great tool, Gripe, I think it was called. I would have shown Trivy, which is very similar. Yeah, but to give you the idea, you should do image scanning. Maybe one thing I want to show you. So let's go over the slides. So image scanning. As already mentioned, I use Trivy now. I think it's image, and we can configure the severity. I'm only interested in critical stuff. And let's try Elasticsearch 6.8.21, and I have to take a look at my cheat sheets, otherwise it's the wrong version. Let's check if log4j stuff is in there. And what did I not do now? Damn it. It's very similar to the Gripe tool. First, this tool has to get the latest and greatest information about the latest and greatest vulnerabilities. So the first thing it does is downloading the latest information. And you see a lot of critical stuff in here, like remote code execution in log4j. So Elasticsearch is a database, a search engine, I do not know. And it's written in Java, and they have log4j in their stack as it looks. And that's the important point. Those image scanners also have to check the dependencies in your applications. So, but to be fair, so in the next version it was fixed, and check the latest version, and they have no critical issues in there anymore. And it takes a long time because it's a huge image, which is also one of the gotchas you already heard at this conference. The smaller your image, the better. This one is not small. No, it's really not small. Yeah, you see it. No critical ones in the current Elasticsearch version. So also, for sure, the log4j stuff has been eliminated. Okay. Pro tip: do image scanning on your local machine. Sure. Even better, in your CI/CD pipeline. Pro tip turbo. Do it in your production environment. So you can also grab the images from your running pods and do some image scanning and do alerting via whatever. So we have created some barrier here. So not everything can get onto our clusters, and this makes complete sense. Now, even the gods come into play. And the god Kyverno backs King Admin. And you have seen Kyverno, I think Adrian also showed it yesterday. And It's about restriction of the workloads. Before we talk about Kubernetes, I want to give you some architectural background of how this works in Kubernetes. There is the mighty API server, and it's a very important component. And the API server does three things. First of all, authentication, then authorization, and then admission control. So if you send a YAML to your API server, which, by the way, gets transferred to JSON already on your machine, the API server, first of all, checks, are you really the person who you intend to be? If true, it cares about authorization. Are you allowed to do that stuff you are intending to do? And the last thing it does is admission control, and we will take a deeper look in this because Kubernetes is an admission control plugin. And if this goes through, the stuff you wanted to apply to the Kubernetes cluster gets stored into the database. By the way, nothing changed besides of the fact that something has been written in the database. That's then the job of the reconciliation loops to recognize this. So, we are talking now about admission control plugins. And such plugins, you can also write your own plugins. We are using some plugins now, which are already written. After the authorization, the authentication, the authorization, you can add mutating webhooks. For example, adding an Envoy proxy to all your pods, like Istio does, or the Vault stuff, which does it very similar. Then schema validation, and then is the validating webhooks time. So you can put in your own validations in here. And afterwards, the stuff gets stored to etcd. Here I have to mention pod security policies. And they will be removed in 2 months, so don't use them anymore. So pod security policies, this was something we used in the past. You could do stuff like this. You can avoid that somebody starts a privileged container and a lot of other stuff. But they are deprecated. So what to do now? What should we use now? And there are multiple options. One option you see a lot is OPA Gatekeeper. Gatekeeper is not implemented for Kubernetes itself. It already existed before. You can use OPA for lots of other stuff like Kafka or sudo permissions and databases and stuff like this. and the thing I do not like that much about OPA is that you have to learn a new language, and the language is called Rego, which I think is a good language, but I'm old enough to say I don't want to learn a new language. I'm still learning new languages, by the way, but not this one. Rego looks like this, so I think it's very easy to understand. So you can say, I don't want to have images from this registry in my cluster. Yeah. Kubernetes is Kubernetes native, so you don't have to learn a new language. And you have the possibility to create specific custom resources, which do exactly the same like OPA Gatekeeper. This is a cluster policy, so you add some thing which is called cluster policy. There's the validation failure action, which can have 2 modes. Enforce, which means, like Gandalf said, you shall not pass, so no way. If it's enforced, Kubernetes will say stop. If you put it on audit, you only get some logging that something happened to your cluster. And for sure, you have to define for which objects and what should trigger all these actions. In this case, if the container image doesn't come from this registry, it will fail. So let's try this. I already installed Kubernetes also on this machine. And I simply have to apply this image, this cluster policy. So kubectl apply -f. I think now it's 10. Yeah, and that's it. But first I have to delete the pod. And now I can reapply it. And that's where Kubernetes should trigger some error message. So let's try it. And we get the error message. So now Kubernetes says, no. This image is not from some strange registry, so you are not allowed. So Kubernetes allows you to build some rules which to allow you to do things or not. Now I want to uninstall Kubernetes for some reason. Kubernetes. Cool. Or not? Oh, nice. Yeah. No demo without any fun. I will simply ignore this now. So this was the God Kubernetes. So we have Kubernetes in place on the API server. I tried to delete it, but it didn't work. Another God, the kernel God, back King admin. And you can do also a lot of security stuff via security tools on host level. I will show you AppArmor. It's a Linux security model. So it had not the goal to support Kubernetes, but you can use it for sure for Kubernetes things. You can also use SecComp, which is some kind very similar. And what you can do here, you can define some profiles. And you can, for example, say on host level, no process, no matter if it's from a container or not, is allowed to write anything. So, and you have to add this annotation to your pods. So now this profile will be used for this pod. So let's try this. Before trying this, I have to ensure that my pod is still running and I can write stuff. Oh. So trying if I can write stuff. Exec minus IT minus touch some file in the temp folder in the container. So it worked out. Okay, cool. Let's check if AppArmor is installed on that machine. It's a Linux service. Status up. No. And it's running, or it's active at least. Okay. AppArmor, you can have these different profiles. So let's check the profile state. And you see here, yeah, some are in enforce mode and some are in complaint mode, or nothing is in complaint mode. So let's add our profile. And this is simply done via copying the file in a specific folder again. So it's, I think, 11. To etc AppArmor D. The profile is not active yet. We have to restart AppArmor. And now when we do AppArmor status, if we can write it, then we see the profile here. So let's engage it in our pod. And this is also done via annotations. Hopefully, this will get supported also without annotation at some point in time. And what we are basically saying here is, in this pod, there's a container which is called myUbuntu, and this one should use this profile. And now we apply it. Pod.yaml. And we have to force it. And now we hopefully cannot write anymore. No. No. Touch temp some file again. Permission denied. Because the host said no. Okay. Sorry, I have to hurry up a little, otherwise I will need too much time. So AppArmor is also a very cool tool to do security stuff. So you add it on a host level, and you can do a lot of fancy stuff with AppArmor, or SecComp, which is very similar. Now, King Admin has a great idea. Does anybody of you know why we call log files log files? Nope. Back then, when King Admin lived, they had chips, and they wanted to know how fast they were going with the chips. And they threw logs into the sea. On the log, there was a rope, and in the rope, there were some knots. And they held the rope, and the log wanted to stay at the position, but the ship was accelerating or whatever, and they counted the knots and wrote the number of knots in a book, which is called the logbook, because log, wood, ship. And so that's the reason. It has nothing to do with the talk, but I only wanted to bring it up. And King Admin, the wise king, also would like to enhance his Kubernetes security with some serious logging. And the first thing he will do is he adds Kubernetes auditing. And that's built in. You don't have to install anything. You only have to customize it. Kubernetes allows you to audit everything. You simply have to engage it. You can define rules. So, for example, we want to know if somebody in the default namespace gets some secret in whatever way, via get, via list, or via watch. And there are some flags which are interested, request received, so the stages. Do I want to have this information when the request was received, or when the response started, or the response was complete, or if a panic happens? And there are also some levels. What information do I want to have? None? Okay, not very useful. Do I want to have the metadata, the request, or even the request and the response? And you have to enable this in the API server. So let's do this. I have to copy again this audit policy in this very nice folder, which is mounted already to the API server. So I do a copy of 12 audit policy to root API server. So the file is in the API server container. Now let's tell the API server about this file. And now I'll do some serious copy-paste again. And you can customize a lot of stuff in this area. What we are doing here is you have to tell where is the audit policy you want to apply. You have to tell the API server where the log file should live, where this information gets logged. And there's a max age, so how many days these log files should exist on the system. Because if you engage everything, you will get very huge log files. And the max size of a log file. And if I didn't do any stupid typo, the API server should start again. Okay, takes a few seconds. It's quite hot in here, on stage especially. Where is he? Nope. Now the API server is gone. Now he's back again. So now I can do a kubectl again. Okay. We told Kube API server, please log every time somebody is writing some secret, is reading some secret. So first of all, let's take a look at the log file. APIs default secrets. A lot of stuff is already in there because things is going on in our cluster. So if we do now a kubectl get secret, my secret, then we should have this in our log file. Somewhere in, yeah, it's the last line here. So you can log a lot of things with Kubernetes. That's the one thing I wanted to show you concerning logging. But there's something additionally I want to show you is the Falco threat detection. So with Falco, you can detect threats. It's built explicitly for Kubernetes. And you can define some rules. And Falco gets delivered with a lot of very good rules already. We will not define any rule now. We simply use Falco. We are simply using Falco in a few seconds. And you have to define where to put the log file again. This is happening on host level again, for sure. And then you can also write your own rules, but that's, for timing reasons, not very... I can do this now. So let's play around with Falco. So this is the last thing I want to show you today. So Falco is already installed on this host. It's running. Let's customize it. .yaml, that's the configuration file. And somewhere in there, here, we can enable the file output. True. And we are on host level, so I can use the directory var log falco.log. Let's restart Falco. And if I didn't do anything stupid, this should be it. Now, Falco gets delivered with a lot of great rules already in there. For example, one rule is that you can get information if somebody does a kubectl exec into your containers. So let's do this. Kubectl exec -rt bash exit and take a look at the log file. And here we go. So whenever somebody execs into your container, you get a logging message that somebody execed into your container. And there are a lot of other fancy stuff about Falco, but we do not have enough time for this now. Okay. So now we have audit logs, Falco logs. The last thing I also wanted to show you, but I think we are running out of time, is benchmarking. Kubebench, take a look. It's also cool. It should tell you all the things you did wrong in your Kubernetes environment. So with Kubebench, if you run a Kubebench run, you get some benchmarking about your own cluster. It's from Aqua Security. That's the last thing. And Hakarios is very sad now. So King Admin was very wise. Some honorable mentions. Small images, distroless images, you've already heard about this. Make your containers read-only. There's a specific flag in your, which you can define in the pods, read-only root file system, which is very handy. Image policy webhooks do exactly the same we did with Kubernetes. Network policies build firewalls in your cluster. Container sandboxing, also very interesting. Instead of running runc, you can use gvisor containers, Kata containers. Yeah, from the security perspective, they bring some benefits. Don't be this guy, because this person will be back. Thank you.